Welcome to the Physics Tips for Cambridge Students YouTube channel. And today we are going to be looking at base units, that is in the AS 9702 Physics syllabus. So I'm going to discuss all about base units, what you need to know, how to deal with quantities, that is base quantities and derived quantities. Then we'll use the February-March 2019 paper 2.2. Question number 1 is our example. Now, before you do anything, please subscribe to my channel, hit the notification bell and share my videos so that they reach as many A-level students as they can. Right, without much further ado, let's get started. Right, so base quantities, there are about 7 base quantities, and these are fundamental, that just occur in nature. They are not derived from anywhere else, so they just occur. These are mass, length, time, temperature, electric current, amount of substance, and luminous intensity. We have got the symbols there, M, L, T for time, small t, please. Temperature is capital T. T normally is in kelvins. And then we've got I for current, and then N for amount of substance. And there's nothing for luminous intensity. Then on the respective units, we have the kilogram for mass, kg is the symbol, meter for length, m is the symbol, small m please, second for time, small s, kelvin for temperature, big K, ampere for current, then big A, mole for amount of substance, MOL the symbol, then candela for luminous intensity. So 1, 2, 3, 4, 5, 6, 7, including the candela. Right, we then have what are called derived quantities and units. These derived quantities have to be arrived at by using a defining equation. So the defining equation normally has these base units or base quantities and some of the derived quantities as well. Also, all derived quantities, they come from base quantities. The first one is area. Now, I need to stress that you need to memorize all these formulae that are used in the AS syllabus. So these you need to know by heart. Density rho, mass over volume, velocity, delta S over delta T, that's change in displacement per unit time. Acceleration, change in v per unit time. F, the force, mass times acceleration. P, momentum, mass times velocity. W, work done or energy, force times distance. Power, work done over time taken. Frequency, 1 over T. Pressure, force over area. Charge, current times time. Potential difference, work done over charge. Resistance, V over I, that is a potential difference over current. Then Young modulus, stress over strain. Now stress is equal to force over area, so it is measured in Pascal, so it's just like pressure. Then strain is the extension per unit length. So extension is measured in meters, length is measured in meters, so it is a ratio. So strain is no unit, so which means the units of stress are the units of Young modulus, which are pascals. Then activity and decay constant, each have the quantity like frequency 1 over time, so the units will be per second. Now looking at the base units or the equivalent base units of derived quantities, once you know the defining equation, then it becomes easy for you to work out the base units. For instance, for density, mass over volume, mass is already a base unit, base quantity rather, and then V is volume, which is L cubed, so it will be kg m to the minus 3. Then if you look at say charge, current times time, both base quantities, and you have ampere times seconds. And then we have got V, which is potential difference, work done over charge. You are taking the units of work done, which is these ones, kg m to the 2 s to the minus 3, times, divided by the charge, which is AS, the units of that. So you divide the two and then you get what you're seeing there. Okay. So you need to know the defining equations. These are the ones that are very important. And then from there, you you simplify the defining equations so that you express the units in terms of the base units that you know. For example, for force, we know kg meters per second squared coming from mass times acceleration. So you then, if anything is got force, then you just put kg meters per second squared, like that. One thing you don't need, you are not supposed to do, is to mix up the quantities in the units. You don't say mass is equal to kg. Mass is a quantity, kg is a unit. So you cannot mix quantities and units. I'll show you a little bit later. Right, now let's delve into the question paper that we need to be using as our example. So this question paper, let's see. Right, it's going to be the February-March 2019 paper 2, and it's going to be there's only one variant for that exam, and that's the paper 2. Okay, so I'm just opening it. Very soon we'll be showing it on the screen. Right, I found it. So let me show it. Right, so the first question over there is the ampere, meter, and second are SI base units. State two other SI base units. So we've got the Kelvin, and then also we've got the kg, or the kilogram. We can also use the candela as well. The average drift speed v of electrons moving through a metal conductor is given by the equation V is equal to mu F over E, where E is the charge on an electron, F is the force acting on an electron, mu is a constant. Determine the SI base units of mu. Right, so the first thing you need to do here is to make mu the subject of the formula. So your mu is going to be equal VE over F. Right? VE over F. And then, like I said, you don't mix the quantities and the units. So you then say the units of mu should equal, then you start on the units of V, which will be meters per second. This is times units of charge, E. Remember, we now need a defining formula there. Q is equal to IT. I is measured in amperes and T is measured in seconds. So we've got AS there. Then force, mass times acceleration. So it's going to be kg meters per second squared. Okay. And then you simplify the indices. So let's start with the numerator. Down there, we have A M S to the minus 1 times S. Then they disappear. Then we remain with the denominator. It's kgm S minus 2. Now, the m's here will cancel again. So, which you then get A kg to the minus 1 S to the positive 2, because this is 1 over S to the minus 2. So that will be the unit there. A kg minus 1 is to the positive 2. So I think that's it. So the thing to do, let's go back. I was saying that we don't mix quantities in it. We don't say equals, because these are now the units if I put the square brackets. Or if I put this, it follows that the units, then after that you start writing the units. Then it makes mathematical sense. Right, so I think that is it. Please don't forget to subscribe to my channel and hit the notification bell so that you get notified of my future videos as well. Right, signing out.